Hello everyone. So in this video, we will be going to discuss about the inverse trigonometric functions. So from the last session, we have discussed the derivative of the trigonometric functions. Now, we are going to discuss the inverse of it. So the derivatives of the inverse of trigonometric functions are this one. So last time, again, we have discussed the derivative of sine, cosine, tangent, and our trigonometric functions. Now we'll be going to discuss the inverse of the trigonometric functions. So inverse of trigonometric functions can be written or is symbolized by a sign with a negative power of 1. So as you can see from here, this is the inverse of our trigonometric function sine. So this one can also be read as arc sine. So sine raised to negative 1 is just equivalent or the same with arc sine. It's also the same or applies with the cosine, the tangent, the cotangent, the secant, and the cosecant. So as you can see from here, this one is just equivalent to arc cos. Tangent raised to negative 1 is just equivalent to arctan, and the rest. So as you can see from here, these are paired. If you can observe, 1 and 2 is paired. Sine and cosine are paired. They has the same, mostly the same inverse or derivative of an inverse trigonometric function. In arcsine, that is the derivative of arcsine is positive 1 all over square root of 1 minus u squared times the derivative of our u. But in the cosine, we will just be negating the sign. So that will be negative 1 all over square root of 1 minus u squared times du over dx. So it would be easier to familiarize and to memorize because sine and cosine, you just have to invert or you just have to negate the sign of the cosine. Same with the tangent and the cotangent. For the derivative of the arctan, or inverse of tangent is 1 over 1 plus u squared times du over dx, in which for the cotangent or the arccot, that is just negative of the tangent. So as you can see from here, we have negative 1 all over 1 plus u squared times du over dx. So they are basically the same, but just negate the sign. And for the secant raised to negative 1 or the arc sec, we have 1 over u times u squared minus 1 times the derivative of our variable or the u. That is just again the same with the cosecant, however, you have to negate the sign. So basically, we have this as our derivatives, or you can also refer to this one. They are just basically the same. I just rewritten it according to the symbol and its equivalent. Arc sine is equivalent to sine raised to negative 1. So you have to remember the derivatives of each of this because you will be using that um, in the further examples. So now let's try to answer some examples that we have here. So we have here our first example, which is the derivative of y is equivalent to our cos of x all over 1 minus x. So that being said, this will be our u so that we can satisfy the inverse of trigonometric function of arc cos. So our angle is the u. So here our angle is x all over 1 minus x. So in which we also have to find the derivative of our u. So we have du over dx. As you can see, this is in fraction form, so we have to do or we have to apply the quotient rule. So from here, we have the denominator, copy the denominator, times the derivative of the numerator, so we have 1, minus the numerator times the derivative of the denominator, which is negative 1, all over the square of the denominator, which is 1 minus x squared. So simplifying this, we have 1 times 1, that is 1, negative x times 1, that is negative x times negative 1, that is positive x, all over the square of the denominator, So as you can see in the numerator, it's negative x plus x is just barely equivalent to 0. So that being said, our derivative of u is just 1 over 1 minus x squared. So now, after we find, or after we have derived our u, we have to remember that the derivative of our arc cos is just the negative 1 over square root of 1 minus u squared times the derivative of our u with respect to x. So now we have to substitute the values that we have here in the derivative. So our y prime now is just equivalent to negative 1 over square root of 1 minus u, which is x all over 1 minus x. So we have x all over 1 minus x squared, because again this is squared here, times the derivative of our u with respect to x. So we have 1 over 1 minus x squared. So after that, we have to simplify our equation in order for us to find our final answer. So from here, we have negative 1. Simplifying the denominator, we have square root of 1 minus x all over 1 minus x squared. So by the principle of the index laws, so we have the x squared all over 1 minus x, that is also squared. That is multiplied by the derivative of u, which is 1 minus squared. So again, we can still simplify the denominator. So we have negative 1, finding the LCD of this one. So we have 1 minus x squared. We also have 1 minus x squared minus x squared times the derivative of our u with respect to x. So we have 1 minus x squared. And then we can still again simplify the denominator by expanding the binomial here inside the radical form or inside the square root. So we have 1 minus 2x plus x squared. Again, we are just expanding this 1 minus x quantity squared minus x squared all over our denominator, which is 1 minus x squared times 1 over 1 minus x squared. So from the radical form inside, you can observe that x squared minus x squared is just basically equivalent to 0. So what we have left now is we have negative 1 over square root of 1 minus 2x all over 1 minus 2x, x only. So we have squared times the derivative 1 minus x squared. So with the principle of the radical form or radical principle, we can separate the radical sign in the numerator and the denominator. So we have negative 1 all over square root of 1 minus 2x all over square root of 1 minus x squared. Then we have 1 minus x squared. So as you can see, we can cancel the square root and the squared. So what we now have left is negative 1 over square root of 1 minus 2x all over 1 minus x times 1 over 1 minus x squared. And for this one, so we have to divide the fraction. So in dividing the fraction, That's understood to have 1 over 1 times the reciprocal of the denominator, which is 1 minus x, all over square root of 1 minus 2x, right? So that is just multiplied as well with this one. So we have 1 minus x squared. So that being said, we have, this is negative. So we have 1 minus x, that's cancel. We can cancel one of this as well. So in the simplified form, we have 1, negative 1 times 1. So it's negative 1 all over, we have still 1 left here. We still have 1 left. So that's 1 minus x. And the square root of 1 minus 2x. So we cannot simplify this any further. So meaning to say this is already our final answer. So this is now the derivative of our arc cos of x all over 1 minus x. So this is now our final answer. So we now have our second example, which is the derivative of y, which is equivalent to arc cot of tangent 2x. So as you can see from here, tangent 2x is our u. So that means we also need to find the derivative of our u with respect to x. So from the previous discussion, or from the previous session, we have discussed the derivative of our trigonometric functions, which involves the derivative of our tangent, which is equivalent to secant squared 2x. So just copy the angle, which is 2x, and then derive the angle, which is 2. So that being said, the derivative of our tangent is tangent 2x is equivalent to 2 secant squared 2x. So from that, we can already derive our arc cot, or the inverse cotangent, which is equivalent to the negate of the derivative of the arctan, which is 1 over 1 plus u squared times the derivative of u with respect to x. So that being said, we can just plug in the values that we have earlier. So we have negative 1 all over 1 plus our u, which is tangent 2x. So we have tangent 2x squared, because this is u squared, times the derivative of our u with respect to x. So we have 2 secant squared 2x. So simplifying by multiplying this one, multiplying the term, so we have negative 2 secant squared 2x all over 1 plus squared of tangent 2x is just equivalent to tangent squared 2x. So basically, you can already have this answer. However, we can still simplify this by applying some trigonometric identities. So if you can recall this one, our denominator has an equivalent trigonometric identities, which is under the Pythagorean identity. So if you can recall, 1 plus tangent squared x is equivalent to secant squared x. However, in this case, we have 2, so that is just still equivalent to tangent squared 2x is equivalent to secant squared 2x. So that being said, 1 plus tangent squared 2x can be replaced by secant squared 2x. So replacing that with the identity, we have negative 2 secant squared 2x all over secant squared 2x. If you can observe as well again, we have secant squared 2x can be divided. If you divide secant squared 2x by secant squared 2x, that is just equivalent to 1. So meaning to say our final answer is negative 2. So this is now our final answer. So again, if you can still simplify or find some identities that you can replace, you have to apply that in order for you to simplify your final answer. Next, we have the derivative, or finding the derivative of our arc sec, square root of 4x plus 1. So in this case, our u is square root of 4x plus 1. And the derivative of that is, the derivative of that will just be changing this into an exponent. So this is understood to be 4x plus 1 raised to 1/2. And the derivative of this is we have 1/2 4x plus 1 raised to negative 1/2 times the derivative of the inside, which is 4. So, simplifying, we have 4 over 2 square root of 4x plus 1. And then, we can still simplify this. So, we have 2 square root of 4x plus 1. So, this is now our derivative of u. So from this, if you can recall from the earlier slides, the derivative of arcsec is just equivalent to 1 over u square root of u squared minus 1 times the derivative of our u with respect to x. So plugging in now the values to the derivative of our arcsec. So we have 1 over u, which is, this is our u, square root of 4x plus 1. And then we have the square root of our u, which is 4x plus 1. That is squared minus 1 times our du over dx, which is 2 times square root of 4x plus 1. So from here, simplifying our answer, we have 1 over, this one can still be simplified. We can remove the square root and the squared. So what we have left now is equivalent to square root of 4x plus 1. And we have square root of 4x plus 1 minus 1. Let's just erase this one. And then we have the derivative of our u. We have 4x plus 1. So from here, 1 minus 1, that is just equivalent to 0. So now 1 times 2, that is 2. Square root of 4x plus 1 times square root of 4x plus 1, that is just equivalent to 4x plus 1, because 1/2 plus 1/2, that is 1. But we still have square root of 4x here. Right? Now, we can still simplify that because square root of 4x can be expanded or can be changed into square root of 4 and square root of x. And square root of 4 is a perfect square, so meaning to say we have a root for that one. Square root of 4 is 2. And then we have square root of x times 4x plus 1. So, cancel the 2. So, the final answer is x times 4x plus 1. So, this is now our final answer. This is the most simplified form of our answer. But if you still want to distribute this, you can still do so.